session Earthquake Resistant Design Philosophy. This is Mr. Chetan Ji Konapure, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. These are the learning outcomes. At the end of this session, student will be able to understand the concept of earthquake resistant design, philosophy behind the design, conceptual and good design features of earthquake resistant. Why civil engineering structures are affected? Most of the structures have their fundamental period or time period near to the predominant periods of earthquake. Now this is ground motion or earthquake as input, and output is amplified structure response. Now what are the responses? Displacement, acceleration, damages, even destruction. These are the responses as output. Input is ground motion through the earthquake. Output, displacement, acceleration, damages. Now in between here structure properties are there, and this structure property may act as amplifier or filter. So we must select those structural properties in such a way that the properties must be filtered so that the output or responses will be controlled. Now this is the design philosophy behind earthquake resistant design. These are the facts. First fact, earthquake proof construction is practically impossible. Structures to resist most severe shaking are too expensive build. This is the second fact. Third fact is most severe earthquakes are not frequent also. Now the objectives of this design philosophy is structure should be able to resist. First, there are three categories of earthquake, and according to those categories, the expectation for the structure or design is given here. First is minor and frequent earthquakes. No damage shall be there for the structure. Moderate earthquakes, no structural damage, some non-structural damage is allowed. Now structural damage means there should not be any damage to the structural element like slab, beam, column, footing. Non-structural damage means we can expect some cracks to the parapet walls to the some extent of chajjas. These are the non-structural element. And for severe and infrequent earthquakes, structural damage is expected, but there should not be sudden collapse. No collapse is expected for severe earthquakes. Now, the earthquake resistant design is based on dual design philosophy. What is this dual design philosophy? First is safety level design, second serviceability level design. Now safety of the structure or safety of the occupants, there should not be any compromised concept for extreme earthquake events. So safety must be ensured in extreme earthquakes for structure as well as occupants. Serviceability level design. Serviceability or utility of the structure should not be unexpectedly disrupted under more regularly occurring earthquake events. So safety level design, that is raised to extreme earthquake. Serviceability level design, that is expected from regularly earthquake. Now our design codes behind which this philosophy is given or considered. Our design codes, how they are satisfying both these performances, safety level design and serviceability design. This is possible through a combination of analysis, design and detailing specifications. Now let's see this, what is meant by this design earthquake. Now design earthquake events are required for both performance criteria. Now there are two earthquakes. This is extreme earthquake event. This is second moderate earthquake event. Extreme earthquake event means it is termed in our codes as maximum considered earthquake, that is MCE. Now it has a very low probability of occurrence. It must not result in excessive casualties or damages, and the probability is 2% only. 2% probability of accidents in 50 years, that is once in 2500 years on the average. Second is moderate earthquake event. This is termed in our code as design basis earthquake, DBE. It has moderate probability of occurrence, must result in moderate and repairable damage, must result in very few casualties, typically 10% probability of accidents in 50 years. So by probabilistic approach, it is once in 475 years on the average. Now, what is design earthquake? What we should consider? Design earthquake events have been decided based on past earthquake data for the particular area or zone. Earthquake severity has been classified on the basis of maximum ground acceleration of that zone. Entire country has been divided into 4 seismic zones based on earthquake hazard. So according to these zones, we must consider the maximum ground acceleration. Zone 2 has lowest hazard while zone 5 has highest hazard. Mumbai and Solapur falls in zone 3, Delhi in zone 4 and Bhuj in Gujarat it falls in zone 5. This is seismic zoning map. You can observe here there are 4 zones starting from 2 to 5. Now entire country is now considered as it is seismically active. Now design earthquake, the first criteria we must consider peak ground acceleration of maximum considered earthquake in each seismic zone which have been decided from seismotectonic studies or past experience. So PGA, peak ground acceleration is important for that zone. Second thing is peak ground acceleration for DBE in each seismic zone is assumed as half of that of the MCE. Means design basis earthquake is having peak ground acceleration half of peak ground acceleration of MCE. Now frequency content of ground motion is assumed same for both the earthquakes for MCE and DBE. Structures are explicitly designed for DBE, design basis earthquake. Safety under maximum considered earthquake is ensured through suitable overstrength and ductility provisions. Okay, so our structures are designed for design basis earthquake, but safety under maximum considered earthquake is ensured through ductility and overstrength of the section. Now, few of the tricks are there for conceptual design. Decisions made in conceptual designs are difficult to modify. So always it must be finalized. Modification is very difficult. Good conceptual design aspects. First, simplicity is expected in the design from earthquake point of view. Regularity, symmetry both in plan and elevation. These things are very important. Modular planning, symmetry and very simple planning which always give you a better performance in that earthquake. No significant stiffness and strength, non-uniformity along the height of the building. Sudden change in the stiffness, sudden change in the heights or difference in the heights is not expected in the building for earthquake resistant performance. Structural system should strike a balance between functional and structural requirements. So proper balance must be there. So second point, important point is structural integrity. All structural, non-structural elements should be well connected. So to behave as an integral unit, structural element, beam, column, frames and non-structural like walls, these must act a unit. Structural stability. Structural path should be available for effective transfer of forces to the foundation. Local geological conditions should be critically studied for liquefaction and settlement potential. Now, for members, structural members, proportioning strong column and weak beam, this is very important in the earthquake. Always the columns must be stronger than beams. It doesn't mean that the beams must be weak. Columns must be stronger than the beams. Next thing is large cantilever portion should be avoided. So while designing or while considering the members, these 2 points are very important. Materials. Structural material should sustain many stress reversals. So which earthquake is giving harmonic type of excitation, that's why stress reversals are expected. Structural material should deform without failure. These are the references for earthquake resistant design philosophies. Thank you.